It's supposed to be 200 up here, right?
Okay. Starters. High grade was a 99. Low grade was a 16. There was actually several below 20% on the exam. Okay, so let's go over this dude. Here, I'm just going to open up a... well, I don't really need to solve this one. So write an error-free hello world program. Public class hello, open curly brace, public static void main, string array args, opening curly brace, system.out.println, hello world, closing curly brace, closing curly brace. All right, make sure you didn't screw up any of the capitalizations or anything like that. So that should have been free points, especially since I think I told you it would be on there, right? All right, what does the new keyword do? Why is it required for working with arrays? So the new keyword is like our real estate agent. It goes and requests memory from the operating system for us. So it's the way that we support pointers in Java. Why is it required for arrays? Well, arrays are organized in contiguous memory. So we need a memory address that represents where's the beginning of the array, because different buckets of the array are offsets off that base memory address. Okay, so the new keyword is used to request a brand new memory address from the operating system big enough to hold enough memory in a row to hold however many integers or chars or whatever it is that you're storing in the array. All right, so new keyword, real estate agent, the dude who requests memory, something along those lines. Why is it used for, why is it needed for arrays? Is because arrays are stored using the base memory address, and then they are walked using an offset from that base memory address based on the index. Explain why the char primitive type is actually stored as an unsigned 16-bit integer. Okay, well, first of all, focus on the unsigned versus the signed. So chars are represented as a mapping between a number and a value in the Unicode character set. All right, so computers like numbers. Chars kind of require letters and symbols and things like that, so we need to have a lookup table that maps between those two, and that lookup table is called Unicode. There are 65,536 unique characters on the Unicode character table. So we need a big enough value to hold all the values between 0 and 65,535 to represent all the different characters that are on the Unicode table. And that requires a 16-bit unsigned value to hold all those numbers. Okay. Questions about that one? Go ahead.
So were you looking for talking about Unicode for that one?
Probably drop the word Unicode, or at the very least mapping to a character set. You know, whether you actually use the word Unicode. Some people I think said ASCII. I gave them points for it, but at the very least something along the lines of characters are stored as numbers, which are then mapped to a character on some character set. Unicode was the character set. Probably should have said Unicode, but if you convinced me that you knew that it mapped to a character set, that was probably sufficient if the rest of your answer was looking okay. All right. Write the necessary code to define an integer array capable of holding 25 integers. So an integer array capable of holding 25 integers. So we're going to have an int array. AR is equal to a new int array, 25. That's the necessary code to define an integer array capable of holding 25 integers. Make sense? Next one, write the necessary code to print all the numbers between 1 and 100,000. You must use a loop. All right, so let me. Well, that's kind of interesting. All right, so I'm going to create a little text box here. I'll left justify it. So I'm printing all the numbers between 1 and 100,000. So this is going to be our for loop for int I is equal to 0, or actually 1. I is less than or equal to 100,000. I plus plus, opening curly brace, system.out.println, I. So we're going to have a loop that's going to go through all the values between 1 and 100,000 inclusive, incrementing by 1 each time. And we're going to print out the current value of I each time through. So it'll be a 1, then a 2, then a 3, then a 4, then a 5, so on and so forth. Does anybody have that paper you can pass forward?
Oh, yeah.
Demetrius, you lucked out. I gave it an attendance quiz. So even though you were like 15 minutes late. Killing me.
I usually 8. This class starts at 10.
No, it starts at 10:05. And make sure you make a note of that for the future. But since you did get here before the sheet was handed in, you can sign it. All right, so this is the necessary code to print out all the values between 1 and 100,000. So a couple of mistakes. People would say like less than 100,000 instead of less than or equal to 100,000. Joe, did you get your name on this? Okay, you already signed it? Start I off at 1. If you started off at 0, then you would have needed to add 1 to it to get the right range of values. So I was looking for, can you build the right for loop? And then hopefully the system.out.println was the easy part. Okay, questions on that one? All right, what does the following code do? So we define a couple of integers. Int I is 5, int j is 10. And then we're going to keep looping as long as I is less than j. So as long as the current value of I, which starts off as 5, is less than the current value of j, which starts off as 10, we're going to print out the value of I. So the first time through, this will print out a 5, right? Then what are we doing? We're adding 3 to I, and we're adding 1 to j. So I became a 8, j became an 11. Is 8 less than 11? Yep, so we'll print out an 8. Then an 8 became an 11, because we added 3 to it, and the 11 became a 12. Is an 11 less than a 12? It is. Print out an 11. So this code prints out a 5, then an 8, then an 11.
Do you want the output as answer?
That's what the code does. Code prints out a 5, then an 8, then an 11. That's what this says. What does the following code do, right? This displays a 5, then it displays an 8, then it displays an 11, all on separate lines. All right, questions on that one? You remember from class when we reviewed for the exam, multiple times I said, remember when I give a sample code like this, I'm asking you to tell me as a whole, what does this code accomplish, not what each line individually does? Said it several times, right?
So basically you're saying that you need to write down an answer off the code.
That's exactly what I'm saying, not basically. I'm saying tell me what the code does. Explain what it does, not what each line does. So I'm not looking for you to tell me that the first line defines a variable named I and sets it equal to 5. That's great. You should definitely know that. And if you put that, you didn't lose points as long as you said the rest of the stuff, right? Okay, you had to tell me what does the logic of this code accomplish? Number 7, write a simple program, so an entire program that illustrates 2 variables with the same name that are distinct because they are in separate scopes. All right, All right, so first of all, you needed to show me you understood the difference between a program and a function. So maybe we call this guy public class scope test. And then inside of here, I'm going to create a couple of functions. Maybe we'll have our normal main. So public static void main string array args. Here, let me stretch this out a bit. And then maybe you have an int I is equal to 5 in here. System.out.println I. And then you maybe have another function. Void another function. Takes no parameters. Actually, if you wanted to be interesting with it, you would take in an int I as a parameter here, and then you can say I is equal to I plus 5. System.out.println I. And then maybe in here you went ahead and called another function, passing it I. So here's a program named scope test. It has two functions in it. First one is our standard main. Main defines a local variable named I. Then we have a second function called another function that takes in an int I as a parameter. What does it do? It immediately adds 5 to it, then prints it out. So this guy is going to print out a 10, right? But up here, after we've called another function, his value has not been changed. So it's still a 5. So it'll print out a 5 here. This scope of I and this scope of I are separate variables. They live in completely separate scopes. And even though this value of I was initially loaded with the value of I from here, they're not connected to each other. Two separate scopes. Make sense? All right. So be able to show me that you understand what a program is compared to a function. And I mean, there was easier things. I mean, you could have just started off and said main, just have an int I equals 5, and then have another function and say int I equals 7. Those are separate I's. Go ahead.
So I think I tried to do the same thing, but would this not really work if I used for loop instead of what a function?
Yeah, so I think what some people did, maybe this was something you did, is you did something like, I think you had an int I like that, and then you had a for int I is equal to 0, I is less than 10, I plus plus.
Yeah.
And then you did something inside of here with that I. This Java's not going to allow you to do this because you already have a local variable in this scope named I.
Okay.
So it's not going to let you define another I in that same scope. So the for loop, you're right, does have his own local scope, but he lives in the scope governed by these curly braces. And since there's already a variable named I in that scope, it's not going to let you define another one. It's going to scream at you and say there's already an int I that lives in there.
But if you do a method, or a function, it's just a variable. So
Yeah. If you had sucked this guy down into here, for example, actually right now it's still the same error, but let me I'll just dump that and then steal that. We'll throw it in there. So something like that would be okay, where you have an int I that lives and dies with this scope and an int I that actually lives and dies with this for loop scope, but definitely these are two separate scopes that don't impact each other.
Question.
So,
If I don't define I at first, but then I put like the for loop with an integer I into it, and then I define I later, is that possible?
That's possible afterwards. Yeah, so you could have done this.
Like
4 int I is equal to 0, blah, 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 like that. And then right afterwards, you could have said int I is equal to 9, like that. This I lives and dies with this scope, and this is a separate scope. So you could have done that. You could have just put this code right here inside of main, and that would have been sufficient to answer the question. So here, yeah, that's like a simple version of this if you want to go that route. Yeah. That would technically answer the question. This int I lives and dies with this for loop scope. And then this is a brand new int I that's unrelated to the scope that was right above it. Make sense? Sure.
So like, isn't your function technically like in main? Like, is that
Well, there isn't I have a loop inside of main.
Okay.
I haven't called a function inside of here. I haven't written a function inside of main.
Okay.
If I wrote a function inside of main, this would be a problem. Would be something like this. If I said void do something, I misspelled it, but it's fine. It'll just be a misspelled function. And then you said system.out.println LOL or something like that in here. This would be illegal code because you've defined an entire function inside of another function. Can't do that. Main is a function in and of itself. Do something is a function in and of itself. We've put them inside of each other. You would have to have that do something defined outside of main. So main is here, begins and ends right in here. Do something begins and ends right here. And they both live inside of the class. Yep, so you can't have a function inside of another function. All right. Number 8, convert 1B9C from hex to binary. 1B9C from hex to binary. 2 different ways of accomplishing this. You could have done the trick, right? So first of all, you got to recognize what B and C are. So we have a 1 followed by an 11, followed by a 9, followed by a 12. That's what those, so a B is an 11, a C is a 12, right? So then you can represent these as 4-bit binary numbers. So this is 0, 0, 0, 1. And then an 11 is a 0, 1, 1, 1. And then a 9 is a 0, 1, 0, 1. Right? That's a 1s, 2s, nope, sorry, over that in the wrong place. That's a 1, 0, 0, 1. So this is an 8 plus a 1 is a 9. And this one is an 8 plus a 2 plus a 1 is an 11. And then a 12 would be an 8 plus a 4 plus a 0 plus a 0. Like that. So that's one way you could have solved that using the shortcut.
Wait, how did you do that?
So there's a shortcut where you can break up 16-bit values, or a base 16 number into a base 4 number by separating each of these guys. So a 1 you represent as a 4-bit number, a B you represent as a 4-bit number, a 9 you represent as a 4-bit number, and a 12 you represent as a 4-bit number. So that's my 12, that's my 9, that's my 11, and that's this guy. Okay, so that's the shortcut. So if you remember the shortcut, we probably did like one example of it in this class. We might have done it in 200 or something, but at some point you've seen this shortcut, right? But if you didn't remember the shortcut, you were still okay. Could have just done this the longer way. Okay, so this is the shortcut. This works for base 16 to base 2. It also works for base 8 to base 2. But instead of using 4 bits, you use 3 bits for base 8. Okay? If you're going to do this the long way, the thing we would do is we would convert 1B9C first to decimal, and then convert the decimal to binary. So if you want to see that, I'll just do it on a second slide here. So 1B9C. So we're going to convert this guy to decimal. So this is a 1, an 11,
Smart kids way.
a 9,
Not smart.
a 12. And this is the ones place, the 16s place, the 256 place, is it a 4096 place?
Sounds right.
16 to the third. So this is the 4096 place. Let me put some more spaces in here. This is the 256 place. This is the 16s place. This is the ones place. So we have a 1 times a 12 plus a 16 times a 9 plus a 256 times an 11 plus a 4096 times 1. And then you add all those guys up.
7068.
7068. So my math matches your math, so it must be perfect. 7068. So that is the decimal version of that hexadecimal number. Okay, so we're only halfway there, Blaine.
Yeah. I realized that like actually I was like,
I don't think you were the only one. So some people just stopped there and just decided, look, I'm tired of this.
I got it right.
You never actually converted the decimal number to binary. So now we need to convert that guy to binary. So what are we going to do? We're going to divide it by 2 over and over again. I'll go ahead and put that on a separate slide just because this text is going to get pretty small pretty quick. That way you have this conversion thing clear. So now we have 7068 from decimal to binary. So this is the other pattern, right? So now this is the pattern where we, shut up! So this is the pattern where we divide this guy by 2 over and over and over again and record the remainder. So 7068 divided by 2. Yeah.
3534.
It's what?
3534.
3534. Like that. 3534 times 2.
That's 0. That's the remainder is 0.
Remainder 0. Okay.
I got that right. So
All right.
I'll read it.
So divided by 2 gives me what?
1767.
1767 with remainder 1. Divided by 2.
883.
883 with remainder 1. 883 divided by 2.
441.
441
Remainder 1.
with remainder 1. Yeah, you can tell the remainder by just looking at this as even or odd.
Yeah.
Yeah. So divided by 2, 441 divided by 2.
220.
220, remainder 0. 220 divided by 2 is 110.
Yep.
Remainder 0. 110 divided by 2 is 55. Remainder 1. 55 divided by 2
27.
is 27. Remainder 1. 27 divided by 2
13.
is 13. Remainder 1. 13 divided by 2 is 6. Remainder 1. Right?
Yep.
6 divided by 2 is 3, remainder 0. 3 divided by 2 is 1, remainder 1. 1 divided by 2 is 0, remainder 1. Then you read it from bottom up. That is 1 1 0 1 1 1 1 0 0 1 1 1 0. 1 1. Do that right? 1 1 0 1 1 1 1 0 0 1 1 1 0.
There's 2 0 at the end, though. I don't know why.
Oh, you mean my other one? It's because if I throw zeros in front of this, it's not a problem. It doesn't break it.
No. 2 0 at the end.
2 0 at the end.
1 1 1 0 0. That's weird.
Well, did you tell me bad numbers? I trusted your math up here.
3 5 3 4 divided by 2 is the remainder is 0, not 1.
Oh.
This guy was a 0.
Mm-hmm.
So that means this guy is a 0. So you're saying I should have just done my own math.
What was the remainder?
All right, so if I copy that, we go back to this guy. These two should match.
No, because you have like 110 divided by 2 with the remainder.
110 divided by 2 is 55. Oh yeah, there should be a remainder of 0. This is bad mojo. Trusted her too much on this.
I'm looking at right. 1 6. 1 2.
There. I'm just gonna do this.
Yeah. No, it doesn't look the same.
And the first value we have here is that one. So it should be 1. Here, look. I'm just going to do this again and do it with my math. All right. 7068. 7068 divided by 2 gives me 3534, right? 3534. Now, if you take 3534, multiply it by 2, you get 7068, so that's a remainder of 0. 3534 divided by 2. 3534 divided by 2, 1767. You take 1767, multiply it by 2, you get 3534, which is the same value there. So we have a remainder of 0. 1767 divided by 2 is 883. And that's going to be a remainder of 1. 883 divided by 2 is 441. Remainder 1. 441 divided by 2 is 220. Remainder 1. 220 divided by 2 is 110. Remainder 0. 110 divided by 2 is 55, remainder 0. 55 divided by 2 is 27, remainder 1. 27 divided by 2 is 13, remainder 1. 13 divided by 2 is 6, remainder 1. 6 divided by 2 is 3, remainder 0. 3 divided by 2 is 1, remainder 1. 1 divided by 2 is 0, remainder 1. Read it from the bottom up. 1 1 0 1 1 1 0 0 1 1 1 0 0. There's going to be some padding in the front with a couple of zeros in the front. $441, that's remainder 0. 220 is 110, remainder 0. 110 by 2 is 55, remainder 0. 55 divided by 2 is 27, remainder 1. 27 divided by 2 is 13, remainder 1. 13 divided by 2 is 6, remainder 1. 6 divided by 2. So this looks right. Did I mess up my shortcut? So this is a 1. This is 1, 2's. Oh, my shortcut was messed up. So an 11 is an 8 plus a 3, or 8 plus a 2 plus a 1. That's an 11. A 9 is an 8 plus a 1. That's a 9. A 12 is an 8 plus a 4. So now these guys should match. All right, so those are the two numbers. We had our 11 wrong in our shortcut. So two different ways you could have accomplished that one. Do it the long way, or make sure you convert your shortcut stuff right. Questions on that one?
So 1 minus divided by 2.
I'm missing a who?
1 divided by 2, you delete it.
Oh. Okay, so that was 8. Number 9, write a method named count spaces that takes a string as a parameter and returns the number of spaces contained within that string. Okay. So we're writing a method named count spaces. So we can say, and this guy's going to return, Luke.
Yeah.
Okay, write a method named count spaces that takes a string as a parameter and it returns, not prints, returns. Returns the number of spaces contained within the string. So this guy's going to return an int. It's called count spaces. It's going to take a string as a parameter. We're going to have a counter that's going to keep track of how many spaces we bumped into. Then we're going to have our loop that's going to go through every element of the string. And each time through, we're going to ask a question. We're going to say if s dot char add Austin I is equal to a space, and this is, I do have a space in there. We'll say count plus plus. So this for loop takes me on a journey through all the characters in S. Each time through, I'll ask, is the current character I'm looking at a space? If it is, increment my number of spaces. After my for loop is done, that means I've gone through every single character inside of S and I've counted the number of spaces that are there. Then I will return, Luke,
I don't want to talk about
count the number of spaces. Make sense?
it, unfortunately.
All right, questions on that one? Number 10. If you missed anything on number 10, I took off 80 points. How can you tell the difference between a class method and an instance method at the time of their definition? So when you're defining a method, a class method has static in front of it. An instance method does not have static in front of it. That's at the time you are defining them. Class methods have static. Instance methods do not. How do you call a class method when you use it in your program? We call a class method using the name of the class in which the method was defined. So that is, methods that were defined with the static keyword are called using the name of the class in which that method was defined. Make sense? Lastly, how do you call an instance method when you use it in your program? Methods that were defined without the use of the word static are called using an instance of the class in which the method was defined. Okay, so when we're defining methods, we use static or we don't use static, depending on whether we're making a class method or an instance method. When we're calling them, depending on whether static was there at their definition, we either call them using the name of the class, in the case where static was there, or we call them with an instance of the class, in the situation where static was not there. Make sense? Okay, we reviewed that in class a couple times. Okay, so if you missed points on that one, I guess shame on you. Shouldn't have been any surprise that it was on the exam. Okay, so if you have specific questions on how I graded a particular question on the exam, come up right after class. I'll stop just a couple minutes early maybe, and you can ask your any questions. If you think I took away too many points, I'll give some back. If you think I gave you too many points, I'll take some back. So otherwise, I can certainly tell you why I took off the number of points I took off. All right, questions, comments, concerns? All right, remember, any bad scores on this can be undone if you come back and do well on the final exam. If you do better on the final than you got on this exam, I'll replace this exam with your grade on the final exam. It doesn't go the other way. So if you got a good score on this one, you can't just mosey into the final, slap your name on it, turn it in, and get this guy transferred there. You still have to do well in the final. All right. And remember, all these extra credit things that you guys might go to doesn't help the exams. It helps your homework assignments. So if you miss a homework assignment or missed a quiz or something like that, those guys replace those scores, and I'll apply those at the very end of the semester. Okay, so at the end of the semester, I'll go through, and you notice in the grade book, there's a little category that says like extra credit token or something like that, EC token. Mm-hmm. I'll go through and I'll look at all your worst homework and quiz scores, and I'll replace those with hundreds. Go ahead.
Have you updated the EC tokens since the last EC event?
I've updated them since the day, like I think 2 days after the last extra credit event. I know I've gotten a couple of emails since then that I need to go through and process and add to it.
I think you forgot.
Okay. If you think you're missing one, go ahead and email me, and I'll double check it. Otherwise, confirm that you did email me the picture of you at the bacon thing, or whatever. I know a couple of people sent me their picture like weeks afterwards or something like that. Yeah, I think yours is in there. Oh wait, hold on. Yours might not be in there yet because you might be on my reminder list.
I remember you responding saying, "Great, I got it."
Yeah, I did. Tasks. My tests. Yeah, you're on the list. Add Alexis, Luke, and Lavatrius. So you're on my to-do list. It'll make its way on there. So you're not missed. Yeah.
So, wait, are you saying you already went through your token?
I did not. Yeah. So at the very end of the semester, what I'll do is I'll go through and I'll take, if you have 3 tokens, I'll look at your 3 lowest grades on homework or quizzes. I'll replace those with hundreds, consuming your tokens. So it didn't help you on your midterm grade or whatever, but in the end, those will be applied. Yeah.
So I sent my email. I don't know if you got it or something weeks ago. Can I just resend the picture again?
Yeah, that's fine. Yeah. If you think you're missing something, and when I put the things in there, if you go and look at the description, every time I put a new extra credit token, I put the words of what you attended. So if you attended something and you're missing something in there, yeah, just let me know. I'll go back through.
Yeah, it shows up.
Yeah, the biggest issue I run into is when students, I usually will give it 2 days. So if you send me it right after the event, you're almost guaranteed to get it in there. But if it trickles in a week or 2 later, then it kind of gets lost in email sometimes. But, we'll make sure they're all in there. So check your own and see if you're missing something. Okay. Any other questions about the exam?
He said was ask questions.
Yeah, if you have specific questions about the grading, come up afterwards, and I'll talk to you about your specific exam. But any other high level questions about the exam, why the answers were what they were, that kind of stuff? Char primitive type, why it's actually stored as an unassigned integer. Well, so computers like numbers. We have this Unicode character set that allows us to map a number to a character. So there are 65,536 unique characters on the Unicode character set. You didn't have to come up with that exact number, but we need to store all the values between 0 and 65,535 numerically in order to map to those characters on the Unicode character set. And it takes a 16-bit value, 16-bit unsigned value to represent the numbers between 0 and 65,535. So computers like numbers, we store numbers and then map them to characters later on. The real part of that question, the meat of that question was why are chars stored as numbers rather than characters? That's the meat of that question. They're stored as numbers rather than characters because computers like numbers, we want characters, and there's a mapping lookup thingy. Okay? All right, so let's start talking about Android. What is Android?
It's a phone.
Okay.
Android phone.
All right. So when something's called an Android phone, what does that mean? What's the actual Android part of that?
I don't know.
Okay. Go ahead.
It's the open source software it's using.
Okay. Specifically the operating system.
Yeah.
Right. So Android is an operating system common on smartphones, but we actually do see Android running on other devices now too. If Google TV has Android running on it. A lot of you go down to our printer down there. That printer's running a version of Android for putting in your username and password, that kind of stuff. So you have that. It's kind of a mobile operating system that we commonly find on our phones, but it can be found on tablets. It can be found on other things like that. Okay, so it's an operating system common on smartphones, we'll say. And when we say operating system, that is the software that allows us as the user to communicate with the hardware. Okay, and it's one of the things that allows us to run apps and that kind of stuff. So what's the antithesis to Android on the iPhone side of things? iOS. So Apple's competitor is called iOS. Okay, the OS stands for operating system. The I is what Apple puts in front of everything. Okay.
Is there a specific meaning for the I, or is it just different?
Well, it kind of started when Steve Jobs came back to Apple. He was listed as the interim CEO. So there was some speculation that, and then then he came out with the iBook, the iMac, the iPod. So he put I in front of all those things. Whether or not that has something to do with the fact that he was the I CEO of Apple or not, who knows? But so at the very least, it's because he started a trend with iPod, and now it's just stuck. People got used to Apple stuff being I something, so now it's a whatever thing. But yeah, some conspiracy theorists might suggest it's related to the I from interim CEO. Because for a long time he was called the I CEO, and then he became the regular CEO again. And he was only interim because Apple acquired Next Computers, which he was the CEO of. And then they installed Steve Jobs as the interim CEO at Apple, pending a CEO search or something, but they never did a search. They just ultimately just converted him to the full CEO again. All right, so Android is an operating system that runs on smartphones. That's probably a smartphones among other devices. All right, so when we write, who made Android? This is a little bit of a loaded question, but the ecosystem of Android belongs to who? Google. So this is a Google product, even though initially Google, I think Google either acquired a company or it was an open source product that they then converted. But this is Google's OS for smartphones, as opposed to iOS being Apple's OS for smartphones. Okay, you do have a couple of other operating systems out there that do run on smartphones that aren't nearly as popular. You have Windows Mobile. You have the BlackBerry OS. So you do have some other ones. There's an operating system I think called Tygen that runs on some of the smartwatches. Tygen, I think it is. But whatever. Operating system. The two popular ones on smartphones are iOS and Android. Now, if you want a little more kind of history on iOS, this is kind of an interesting. Apple's, we have this thing called a library. When we've been used to using the Java library. So what's built into the language without us importing anything else is java.lang. So this is the library of all the things that are available to Java without you having to do anything special. Apple has a library called Cocoa. Okay, so they have a library called Cocoa for their desktop operating system. For iOS, it's called Cocoa Touch. So kind of if you ever are looking at Apple documentation, you see something that says Cocoa Touch versus Cocoa. One is a touch-based one for fingers and I guess toes if you wanted to get weird. And the other one is for keyboard and mouse manipulation. All right, so that's Apple's mobile specific library. All right, but we're going to focus on Android in here, but I am going to, as we get into it, I'm going to make comparisons between the two platforms. Okay, because one of the things that I want to keep emphasizing in all of my classes is this idea that the language doesn't matter, right? The fact that we're going to be using Java in here to accomplish some stuff, we could just as easily be using Swift or Objective-C to write iPhone stuff. We're going to see that there's a lot of similarities between iOS and Android. There are differences, but there's far more in common than there is not in common. So as a computer scientist, if you can learn the fundamentals, the theory behind these things, adapting your base knowledge to new technologies becomes very quick. So if you're already an Android developer and you want to go and learn iOS development because you're writing an app and you want to put it on both app stores, learning iOS is not that huge of a deal. You already have a pretty decent foundation on kind of the cadence of how mobile applications work. That makes some sense? Then it's just a matter of like, how does Apple accomplish this versus how does Android accomplish this? Kind of like MVC. We're going to talk about MVC in here as well. Okay, so I'm going to create so we're going to say Android app. This is a collection of something called an activity. So collection of activities. That's what an Android app is. What's an activity? An activity is a collection of views. What's a view? A view is anything you can see on the screen. Now, really, we should say an activity is a collection of views and back-end logic. Where a view is anything we can see on the screen. Okay? Now, if we take this exact same slide, I copy it, and we talk about the iOS equivalent. So iOS app, this guy is a collection of something called a UI view controller. It's a collection of UI view controllers, where a UI view controller is a collection of UI views and back-end logic, where a UI view is anything you see on the screen. So a majority of those slides were the same, we just changed the verbiage just a little bit, right? This is not an earth-changing type of thing.
Seems to be how Apple rolls.
Well, I mean, who came out first? Android or iOS? Which hit market first?
iOS, I think.
iOS by a year and a half. Who had the App Store first?
iOS?
Was the App Store available for iPhone the day iPhone came out?
No.
Nope, it came out a year later. So, yeah, Apple's App Store was the first App Store ahead of Android. So iPhone beat Android by about a year and a half to the smartphone market. iPhone's App Store beat Android by about a year. Okay, so it's not necessarily surprising. If you're a mobile application developer, you're going to make your most money if you develop for both platforms, right? You know, come up with a good app, put it on both, and now you have a larger group of people buying your stuff. But if you only had to pick one platform and you wanted to make the most money, the correct platform is iPhone. And there's no real debate there. You know, there's plenty of debate between, you know, like which operating system is better, Android or iPhone. We can do the whole thing. I bet you if I ask who's using an iPhone, half of you raise your hands. Who uses an Android device, the other half will raise their hands. You know, you're going to have that in almost any room, right? You know, there's a pretty even divide between who likes iPhones versus who likes Android, that kind of stuff. Go ahead.
So if you really had to choose one to make more money, if you
iPhone.
Why would it be iPhone?
Far more affluent users, I think part of it is. See, numbers get very skewed. If you look out there and you see the Android proponents, they would say that, oh, there's far more Android devices than Apple devices when they view that. The issue is that Apple makes all of their devices that run iOS. So 100% of devices that run Apple's mobile operating system are made by Apple. On Android, Google provides a software, and you have, you know, zillions of companies that make zillions of phones that all are running that. This ranges from your, you know, flagship phones that are legitimate competitors with iPhones, like your Samsungs, your Pixels, you know, your higher end HTCs. So, you know, the expensive phones. You take any phone on the market that is like an $800 phone. These are in the same class phone as the iPhone. Mm-hmm. iPhone doesn't have the equivalent of that $100 phone, where that does exist on the Android side. And I promise you, you will not have as good of a user experience on a $100 Android phone as you do on an iPhone, but you'll save a lot of money. So it might be a good enough end user experience if you decide that route. the numbers get a little skewed when you look at the total number of devices that are running Android. It's a much bigger number. People with iPhones tend to update their devices more often. Okay, so a lot of times you have one device that cycles out and another device that cycles in, so you don't actually get an increase in numbers, but they're running a newer version of the phone. So they're running. It's much more common on the iPhone platform for people to be running the newest version of the software, whereas on the Android platform, it's all over the place. Okay, anybody in here have a Pixel 3, one of the new Google phones, or a Pixel or a Pixel 2? Anybody have any of the Pixel phones? Okay, so I have a Note 9, which is Samsung's newest, latest, greatest, whatever phone. I'm not running the latest, greatest version of Android. It hasn't dropped for this yet. So I'm running the previous version. Okay, so the latest version of Oreo, 8.1, blah, blah, blah. Okay, where the Pixels, they get the first update to the latest, greatest software. Okay, yeah. So, punchline is that across Android devices, you have all sorts of fragmentation on what operating system those devices are, what version of Android those devices are running. So if you have a 4-year-old Android phone that's running a 4-year-old version of Android, you can only take advantage of apps that were written to take advantage of components, views that were available 4 years ago. If somebody writes an app and targets the latest, greatest, newest, Android platform, stuff that was just added into Android 1, for example, I can't even run it on my brand new Note 9 because they're using some widget that isn't available on the software yet. Kind of get the problem with Android? Well, the perceived problem. Where you have to go back. I mean, you do have people who are running iOS that are not always running the latest software. It's much less common for anybody who has an iPhone that is, within a couple of years old for them not to be running the latest, greatest. The phone usually screams at you enough to just run the update and then you finally run it. So you're usually running Apple's latest software until Apple stops supporting your device. And then there's some sort of cap. This is the newest software that will work on your device. So it becomes a little bit of a hard comparison. I think the fairest way from a technologist perspective to look at the two platforms is to just treat them as equals. I think it's fair to say that Android, certainly the premium line of Android, is a relative equal to the premium line of iPhone. That was not always the case. In the early days of, I think in 200, I talk about the comparison of iOS versus Android. So we had like the battery life stuff, things like that. Yeah. Okay. Yeah. So I won't go back into that, but it wasn't always that way. But I think realistically today, we can certainly make the argument that, the flagship Android devices and the flagship iPhone devices are legitimate competitors. You pick the one that fits your whatever the best. Android is going to let you run some apps that would never make it onto the App Store on iPhone because of their restrictions for different things, where you don't have to distribute an Android application through their App Store. You can just go and download it from some third party if you really wanted to. So some questionable applications that you might be interested in, you could probably find in for Android, where you wouldn't be able to run those on your iPhone minus jailbreaking your iPhone or something like that. All right, so if you're a hobbyist and you like to tinker, Android's probably your better platform. If you want stuff to just work and be tightly integrated specifically into the Apple ecosystem, so if you're an Apple user and you want stuff to just work, hands down, iPhone's the better experience. It's a tightly knit ecosystem and you don't have a lot of control over the stuff that's in there. So pick your poison. There's pros and cons to both. If I was buying a phone for Grandpa, I'd probably put an iPhone in his hands. Okay, just less to go wrong, I think, generally speaking. Okay, but in any case, we see that there's quite a bit of overlap here between iOS and Android in terms of like the ecosystem of it, right? Now, I'm going to take it one little step further. Now I'm going to differentiate them a little bit. So for iOS in general, what we have is we have a top level view controller. Well, here, I'm going to actually do it in, no, I want to do it this way. We have a top level view controller that governs all of the other view controllers that make up the app. And what this ultimately says is that an iPhone app is self-contained. So it's they really live in two completely separate ecosystems. Okay, so if you have two apps on your iPhone, these guys, it's very difficult for them to talk to each other. Apple has put in some mechanisms to sort of kind of let you do it by leveraging the iOS operating system itself, where you can have this guy write to the operating system, this guy read from the operating system, and now they can sort of kind of talk to each other. But generally speaking, an app is a self-contained type entity. So when we talk about iOS as an OS, at any point in time, we have a collection of apps running. Okay? So a collection of apps that are running. Now, Android actually works much closer to that now. But I'm going to kind of give you the framework for Android behind the scenes there. So with Android, Android OS is a collection of running activities. Now, these activities might be part of various applications. Okay, so let's say that you have two apps running on your phone, and one of the apps has 3 screens on it. Okay, you can pretty much assume that a screen equals an activity. Okay, in Android, a screen, something a screen in your app, like the login screen, would be an activity. The main screen in the app would be an activity. Each screen in the app would be considered an activity. So in Android, if you have one app that has 3 activities and another app that has 5 activities, the Android OS would be running a maximum of 8 activities simultaneously, depending on which screen you're on and if you've gone back to the previous screen and that kind of stuff. So it's actually the operating system itself that holds this collection of activities. So what you actually had with Android several years ago was, how many of you are Android users in here? Okay. How many of you are iPhone users in here? Okay. Just about half and half. Actually, I think iPhone might have won this crowd, but regardless. In iPhone, it's very common for an app to have a back button, right? Is it common for an app on Android to have a back button? Why?
Most Android phones have a built-in back button.
Yeah, Android ecosystem has a built-in back button. So every Android phone will have a little back arrow somewhere where, it takes you to the previous activity. Okay, so if you go back to older versions of the Android operating system, if you were in an app and you were on screen 2 of the app, and then you went back to the home and launched a different app and you were on screen 3 of that different app. Well, let's say you were on screen 1 of that different app and you hit the back button, you would go to screen 3 of your other app. Because the actual operating system was a stack of running activities. And within that stack, you might have activities from different apps intertwined. Okay, so some of you who have been Android users for a long time probably remember at some point a version of Android where you might hit back and actually it switched apps on you because that was the last screen that you were on from the previous app, right? If you are a more recent Android user, that doesn't happen anymore. Okay, because now what they've done is they've compartmentalized each app running in its own virtual machine. Okay, which makes a lot of sense because Android is written using Java, and Java is all about virtual machines.
It still sometimes does that. You open an app, or you click if you have one app open and you click a link, and it opens Google Maps, you press back, it'll go back to the previous app.
Yeah, but that's because it opened Google's map within the context of that app you were just in.
Okay.
So you are right. You are right that you could create that scenario again, but before it was really a problem.
Oh, yeah, it was,
Yeah. Before that back button could just do almost anything. It really depended on what you were doing 5 seconds ago. Okay. Now they're much more organized. So you can almost look at Android and iOS now from a usability perspective as being pretty similar, right? When you hit the back button, you're going back to the previous screen within the current app you're running. And if you get back to the main screen, you hit the back button, it closes the app-ish. It closes-ish the app. That's always a funny thing, especially with iOS versus Android for what's running in the background versus what's not running in the background. Over the years, Android's got better and better and better at hiding their bad multitasking. And Apple had almost no multitasking early on, then had really, really, really good multitasking, and now has decided that their batteries are so good that they'll cheat a little bit and let you have less efficient multitasking at the cost of worse battery life, but it also makes the phone clickier. You know, you can move between applications more quickly because the application was actually still running. You know, instead of you having to like relaunch Chrome, like if you think about your laptop. You know, what do we do on our computers? We minimize Chrome, or, you know, we go and work on Microsoft Word or something like that. When we want to use Chrome again, we just pop it back open. It's left off right where we left off, right? In fact, if you had a YouTube video or something playing in the background on Chrome and you minimize it, that video will keep playing, right? Because that application's still running. Well, old school iOS, when you put an app in the background, that app's shut. Okay. Then they came out with kind of their halvesy multitasking, which was a really good model for mobile applications, where certain applications, when they went into the background, could register themselves with certain components of the operating system. So the best example might be like a music playing app. When that app, you know, if you wanted to listen to Pandora in the early days of the App Store on iOS, you had to have Pandora open. Well, then when they added multitasking, when Pandora went into the background, the Pandora app would then register itself with the music playing capability of the operating system. And it would keep your app going even though a majority of the Pandora app was closed.
Okay.
Make sense? So Apple, and that was really a very good multitasking model for a mobile device. Made a lot of sense. The trade-off, though, is next time you opened up Pandora, it had to relaunch the app, you know, kind of take over control. So you have to wait that, you know, little hiccup for it to launch the app. Where Android never had that problem because Android just ran it runs a Linux-based multitasking model. So it's running a multitasking model as if your computer's plugged into the wall. It doesn't care that you're running off a battery. Okay. So early days of Android, you could switch between the apps super fast. Okay, but you got a 4-minute battery life. Use it wisely. People carrying around backpacks with car batteries in them. So it's, you know, these are decisions. These are technology decisions. It wasn't that, you know, the technology, the batteries that were in Android devices were lower quality batteries than were in, you know, the iPhones. In fact, they probably all came from Samsung or something. You know, they're probably made from the same place. Apple has moved into their own battery manufacturing a little bit over the last several years, but in terms of quality of batteries between these different devices, it's going to be negligible. At some point, it's going to be how efficient is the hardware and how efficient is the operating system at, you know, using the battery life. Does that make some sense? Mm-hmm. Okay, so let's stop there for right now. The next Bible homework is up. If you can, between now and next class, this isn't anything to turn on or to turn in, but go to developer.android.com and go to Android Studio and download that for your computer, and then open it and run all the updates. Okay, this is something you probably want to run like overnight or something like that because there's like 1.5 gigs of updates or something like that, just to kind of prepare your machine for us doing Android Studio stuff. It works on Linux, it works on Windows, it works on Mac. So just download the latest version of Android Studio and make sure it's all up to date. All right? Questions, comments, concerns, bribes. If you have a question about your exam, go ahead and bring it up. You could probably bring your bribe